So dear class, as you can see, uh, we are going to discuss the potentiometer. How can we use potentiometer to find out the internal resistance of a given primary cell? You can see the circuit is looking very complicated, but it is not complicated at all. I can replace this circuit like this. So this is our battery B. Some series resistance rheostat is connected to it. Then we have a wire. This wire is in the form zigzag form, A and 100 centimeter. This wire, this long wire, I can replace it by a straight wire. Then this point A, because positive terminal is connected to A, this point C. This point A is connected to some battery, some cell whose internal resistance you want to calculate. So this is its internal resistance. In parallel to it, you have connected some resistance box and one key, and this whole circuit is connected to galvanometer, and you want to find out its balance line. So this is very simple circuit, not a complicated one. I am going to tell you how can we use this potentiometer to find out internal resistance of the cell. Before that, we must know few things. When we were discussing EMF, internal resistance and terminal voltage, we got the relation between EMF and terminal voltage, and we got that EMF is voltage, terminal voltage plus I into internal resistance. This terminal voltage is nothing but I into this external resistance, right? So remember that this terminal voltage is equal to I into external resistance R. So step number 1, while performing this experiment, we will pick out this key K2. We will switch off this circuit from here, and we will find out the balance length. So when key K2 is open, then we will find out the balance length, and that balance length will correspond to the EMF of the cell. That balance length will correspond to the EMF of the cell, and let us name the balance length as L1. Why it will correspond to EMF of the cell? Because current is not going into this circuit, this part of the circuit. So this will simply calculate the EMF of the cell, right? Then step number 2. In step number 2, we will put this key into the circuit and we will close the key. Now the switch is on. Here the switch is on. Here the switch is off. We will find out the balance length. When key K2 is closed, then you will get some different balance length, L2, and that balance length will correspond to the terminal voltage. Why? Because when this key K2 is open, then these 2 points are at potential called V, terminal voltage, because they are in parallel, and in parallel potential is same. So that potential corresponds to the potential drop across the resistance box, external resistance R. So when key K2 is closed, then you will get this balance length L2, and this L2 corresponds to V. Once you understand this concept, then rest is the mathematics. I can write E is equal to KL1. I can write V is equal to KL2. And you know that EMF is greater than V. So L1 must be greater than L2. Right. Divide these two equations. Once you divide these two equations, you will get E by V is equal to L1 by L2. Now we know E is equal to V plus IR. V plus I small r. So I can replace EMF by V plus IR divided by V is equal to L1 by L2. In next step, I can separate these two things. So I can write V by V will be 1 plus IR upon V is equal to L1 by L2. In the next step, this 1 will go here, and this voltage I will replace by I into capital R. So this equation becomes IR by I capital R is equal to L1 by L2 minus 1. If you simplify it, you'll get L1 minus L2 divided by L2. I will cancel out. You will get the value of internal resistance R is equal to R bracket L1 minus L2 divided by L2. So this is the equation that we are getting. R is equal to small r is equal to capital R, L1 by L2 minus 1. Right? So this is the method of getting the internal resistance of a cell. And there are very simple questions which are asked in exam. One such question is this, given in your exercise. In a potentiometer arrangement, a cell of the EMF 1.25 volt. So EMF is given 1.25 volt. It gives balance length. So balance length corresponding to E1 is L1. It is given 35 centimeter. If the cell is replaced, I replace this cell by another cell. I don't know the EMF of the cell. Its balance length, the new one, balance length is given 63 centimeter. You are asked E2. It is very simple question. You can just think of the formula which is linked by these four things, four physical quantities, and the formula is E1 by E2 is equal to L1 by L2. Just put the value of L1, L2, E1, and you will get the value of E2. So that's all for this lecture. Any doubt, you can ask me anytime.